just as a little bit of a review. So if you look up here, I have question number 1. How many grams are in 1.20 times 10 to the 25th molecules of carbon dioxide? Now, we're starting at molecules. So if I look at my flux capacitor, where am I starting at? Where am I at, Logan? I'm down here at representative particles, right? And I want to go to what? Mass. Do I have a direct line from rep particles to mass? I do not. So I have to go through moles, because this is going to be a 1, 2-stepper, right? A Texas 2-stepper. So I'm going to go from rep particles to moles, moles to mass. So I come back to the problem. I'm going to start out with 1.20 times 10 to the 25th molecules of carbon dioxide. I do my conversion box, and I see my flux capacitor. I know that 6.022 times 10 to the 23rd molecules of carbon dioxide is 1 mole carbon dioxide. When I do my math, I get an answer of 19.92. Let me go on, whatever. I'm going to leave it 19.9 mole CO2 with the amount I left in my calculator. So when I come down here, it's a 2-stepper. I'm not done yet. I have 19.9269, part of the number that I got, mole of carbon dioxide. In order to get it into a mass, I need to know the molar mass of carbon dioxide. So I'm going to calculate that at 8.9994. There are 2 of those. And add that 12.0107. It'll give me 1 mole of CO2 has a mass of 44.0095 grams of CO2. I get a council of my moles of CO2. My final answer is going to be in grams of CO2. So I'm going to take my 19.9269 and I'm going to multiply that by the 44.05. 1, 2, 3 significant figures. So I'm going to get 877 grams of carbon dioxide, which I'm pretty pleased. A lot of you hit that right on. Now, do I have any questions about that? You're going to see problems very similar to this on tomorrow's stoichiometry, check, on tomorrow's molar conversion quiz. So you better make sure you know how to do them. All right, Logan. On this step right here, I don't round anything until the very end, just to prevent, rounding errors, because the more I round, the further off my number gets. The further off my number gets from the actual value. Okay? So, even though I didn't write them all down, I usually keep those numbers in my calculator when I'm calculating and use the big long one, right? Yeah, this is all right. So the second part of my problem is a percent composition problem. It says a compound consisting of carbon, hydrogen, and oxygen weighs 40.85. Analysis show that the compound contains 10.9 grams of carbon, 0.90 grams of hydrogen. What is the percentage composition of this compound? Now, one thing I see here is they do not give me the mass of the oxygen, do they? So, I need to calculate the mass of the oxygen. How am I going to do that? Well, I'm going to take 40.85 and I'm going to subtract, first of all, the amount of carbon, which is 10.90. And then, so I have 29.95. Then I have to subtract from that the amount of hydrogen. So, the mass I have for oxygen should be 29.05 grams. Everybody okay with how I did that? Now, come through. Say, okay, I'm going to start out. I'm just going to do them in the order that they have them done, and I'm going to round mine to 2 decimal places after. Okay, 2 decimal places after. So, carbon is 10.90 out of the 40.85 grams. Multiply that by 100, and that's going to give me 26.68. Hydrogen, 0.9 grams of the 40.85 grams. Multiply that by 100. That gives me 2.20%. And finally, the oxygen, which I just calculated, 29.05 grams of the 40.85 grams. Multiply that by 100. And it gives me 71.11%. Now I'm going to check that. I'm going to add my percentages together, and they should come up with somewhere close to 100%. And when I add them together, I get 99.99. So that's very close to 100, so I'm going to say yes. I'm correct there. Okay with that. Any questions over that particular example? Okay.